here that we're going to examine. And the driving questions that we have here, if we take a look, is why can some things burn while other things cannot burn? Why does ethanol behave more like wood than like water? So we see here we have our ethanol, which is over here. We have our water, and then we have some burning wood. Now, we know the water doesn't burn, but we know that ethanol and wood both burn. Ethanol's a liquid, wood's a solid. What makes these two similar, and what makes this so much different? So we're going to take a look at that. When we look at these things at the macroscopic scale, or what we can see with our eyes, we notice that the wood is obviously a substance that comes from trees, or it has some source to that effect. Water, we know we get it out of the tap. And then obviously ethanol we're still learning about, but we know it's a liquid that actually burns and it's a fuel. So we know that wood is also a fuel as well. So macroscopically, we can tell that these things both produce heat and light, whereas this does not do that. If we look at the large scale in our world, we see that water, we know, is a valuable resource on our planet, and it comes from all different places, and we have large lakes and oceans and things like that that contain a lot of water, and we also have water that's in the ground. But we know that water goes through the water cycle, where you have evaporation, condensation, and precipitation. Wood, we know, comes from trees and forests, in which we take a lot of wood from those particular areas so that we can use it for whether it be firewood or building things. A lot of us don't know that petroleum is a source of, which is also known as a fossil fuel, is where we get our oil, and we get a lot of our fuels from, is petroleum, which is deep inside the ground, which is fossilized plant and animal material that's been under enormous amounts of compression and heat and a lot of time too spent under those situations to give us this petroleum, which is a non-renewable source of energy. We start to zoom into these things. We know the water droplet we've looked at before, and we know that we start to see the water droplets here and all packed together in the droplet. If you look at paper, which is similar to wood, these are paper fibers, and you can see that microscopically we can look at that and examine the wood and see what it looks like. And then we know ethanol is a little different from water. It has some different atoms in it. And then you can compare these two pictures. There are different appearances. But at the atomic molecular level, we can examine those, and we have models for those. So let's take a look at these from the atomic molecular scale. And if we zoom in, we have our water molecule here, ethanol, which is here, which is C2H5OH, and wood, which is hold on a second here, let's get that off the screen here, C6H10O5. And so we see that each one of these molecules has some different atoms in them. So that's the first thing we want to do, is what atoms are found in these materials. So first off, if I look at the water molecule here, and I get my pen out, and let's go to blue, we see that water has hydrogen in it. And it also has oxygen. And we can see those atoms that are in there. So those are the type of atoms that are in the water molecule. If we come over to the ethanol molecule, we do see hydrogen. We also see oxygen. So similar to water, we have those two things. But we now see a new atom that's in here in the ethanol molecule. We see carbon, which a lot of us already knew that, and we're starting to examine that with some of our demonstrations and things. Down here in cellulose, you see that there's a lot more atoms to that. The molecule is very big and long. They use the subscript N to represent how many of these are clustered together. So each C6H10O5 molecule is right here, and you could have thousands of these strung together to form cellulose, which is a long chain carbon molecule. But again, you see that there's hydrogen in this molecule, just like our other ones. And you see oxygen. And then you also see the carbon in this as well. So as you can see here, different similarities. Ethanol and cellulose both have the same atoms in them. whereas water only has hydrogen and oxygen. Key thing to keep in mind there. All right, let's proceed to him here. All right, let's go to the next slide. All right, so what bonds are found in these? We want to clear our screen there. What bonds do we have in this situation here? We're going to look at those too in terms of the different bonds that are located in these particular atoms. So if I take a look and I get my pointer out again. All right, in the water molecule, we only have one type of bond, and that is an OH bond. Okay, and that one there. But if we come over here, we have some different types of bonds because 3 elements. We still have the OH bond, but we also have a lot of these CH bonds, which you see are yellow. And we have also some bonds that are known as CC bonds as well. So we can see that in that molecule here. If we come down here, we have the same thing. We have an OH bond. And we also have CH bonds, which are located here. And we also have CC bonds. And the CC bonds are also highlighted in yellow as well. So maybe get my pen here and make sure we understand that these bonds are yellow, and that for a particular reason, they're highlighting these bonds here. But you can see not many different types of bonds in the water and quite a few in that one there. So what bonds are found in these materials? What we need to understand is that these bonds that are CC and CH bonds are high energy bonds. And the type of energy we're talking about is chemical energy. So this chemical energy is what enables these molecules to burn. So if a molecule has a CC or CH bond in it, it is highly capable of burning if you combine it with oxygen and you ignite it. And we know that both ethanol and cellulose burn. But if we come over here to the water molecule, we don't see any CC or CH bonds in them. So we know that that contains no chemical energy, whereas these over here both have chemical energy in them. Both of these molecules do. So matter and energy is an important concept to understand. Atoms tell you about the matter involved in these situations here. And we can see that we're pointing to this hydrogen atom here. So atoms tell you about the matter, while bonds tell you about energy. So how much energy a molecule has is dependent upon the bonds that it has. So bonds and energy are related, whereas atoms and matter are related over here when we're talking about matter. So do understand the relationship between the two. We have atoms for matter and bonds for energy when we're examining molecules. So materials that burn, as you can see here, we have a bunch of materials. They all have CC and CH bonds. We have wood, we have butane, we have propane, we have ethanol. All these materials are going to burn because they have the CC and CH bonds in them. Whereas if we come over here to this other side, we have materials like water and salt, sodium and chlorine, carbon dioxide, oxygen, nitrogen, both molecules found in air. None of these things will actually burn on their own. None of them have those high energy bonds that are over here on the other side. Well, what makes these things burn? I think I just explained that. We have the high energy bonds that you can see on that left side, and on this side you don't see those. And so that's what makes some things burn. You can hold up a match all day to salt and it won't burn. Water, the same thing. Some people will say, well, oxygen burns. Well, oxygen is what allows things to burn. It's not really going to burn on its own. So water, ethanol, and wood all have the CC and CH bonds in them. And that's what makes them considerably different, and that provides them with the chemical energy which allows them to burn. And that's what is the true definition of what something is that's organic. So in the organic world, when we're defining something that is organic, like this word is right here, it means it has to have CC and CH bonds in it. So that means if it has those, it's an organic substance. So wood, butane, propane, ethanol. Butane is found in lighters. Propane, a lot of you may have that as a source for your home heating. And then ethanol, we know, is in some of our fuels that we put in, even in the gas tank. Well, in gasoline, there's a certain percentage of ethanol. We come over to the other side where we have inorganic things, okay? These do not have these bonds. They don't exist in the inorganic world. So inorganic substances like salt and water, carbon dioxide, none of these have those bonds. So they're considered inorganic, and that's the world that they live on. So organic things we know will burn, and we know have CC and CH bonds. How can we identify organic materials without seeing their molecules? Here are some facts. All living things are going to be organic. Plants, animals, decomposers, anything that out there that you see is living, that's an organic substance. We know that that has CC and CH bonds in their materials that make up those animals. Dead things, things that were once alive, sticks, leaves, wood, cotton, silk, all those substances that you see around outside, anything that was once alive is organic. Foods, anything that is a food, and everything that most of the stuff that you eat, the exception being water, is going to be contain organic materials. So ironically, we drink water, which is inorganic, but all the food we eat is organic. Fuels, coal, natural gas, candle wax, gasoline, all these things are organic also. And then finally, one of the more confusing things is plastics. Now, we think of plastics as something artificial, but if you think about it, plastics burn, and plastics actually come from petroleum products. So they actually are derived from oil that is taken out of the ground and then refined and turned into those plastics. So plastics are organic. So how do we compare these things based on their properties? We know that organic is materials that started as foods, fuels, or living things. And inorganic materials are things that were never foods, never fuels, or never things that were living. So that concludes what's organic and what's inorganic. Think about that original question that I posed here at home. Is diamond organic or inorganic? And the same thing for coal. If you could answer that, you got a pretty good idea of what something is that's organic or inorganic. And feel free to post something in the stream too for fun. Take a picture of something and put it out there, or something that you found that is organic or inorganic. Have a great day.